Microsoft hack that led to breach of U.S. officials' emails. If you have not been paying attention, 2 months ago Microsoft was hacked by a Chinese hacker with the pseudonym Storm 558, which led to the compromise of the emails of senior U.S. officials. Microsoft has finally released a report on their investigation into this hack, and in this video, we will be exploring what are the flaws that lead to this compromise. Let's first go back to June 16, 2023, when Microsoft discovered the presence of strange user activity on various accounts. An investigation was launched to ensure nothing fishy was going. What it revealed was rather around 25 organizations, government agencies included, in the public cloud had their workers' emails compromised. By the time this was noticed, it had already been going on for about 1 month. What made this breach particularly significant was the fact that the actors were able to get into the email accounts of senior U.S. officials like Commerce Secretary Gina Raimondo and Congressman Don Bacon. Microsoft revealed the hacker to be Storm 558. For essence of this video, we will refer to them as Stormy. So Stormy is believed to be a China-based hacker, which primarily targets government agencies in Western Europe. They generally focus on espionage, data theft, and credential access. The way the emails were compromised was that Stormy got access to a Microsoft account consumer signing key, which was used to forge authentication tokens for accessing user email. You might be asking yourself now why a consumer key was able to be used to access enterprise email. Well, there were 2 development flaws that led to this. Firstly, let's go back to 2018 when Microsoft released a new feature to Azure Authentication. At that time, applications using Microsoft Active Directory had to be separated between consumer applications and enterprise applications. So if you wanted an application to be both consumer and enterprise targeted, you'll have to maintain 2 code bases for that. This new feature was a popular request from developers to have the possibility of using both consumer and enterprise accounts in the same application. The solution Microsoft provided was an API that validates security tokens signed by a consumer or enterprise key. But there was one issue. This API only validated the authenticity of the tokens and did not validate the issuer scope to ensure if it is a consumer key or enterprise key. Now this led to the second issue in 2022. Microsoft wanted to update the mail system to use the new Azure Active Directory API. The developers working on this assumed that the API provided complete validation including the issuer scope validation, and they did not perform this on the security checks when doing the update on the email system. These 2 design flaws lead to the possibility of using a consumer key to access the enterprise-related data. Now you might be thinking that despite these flaws, the consumer key still needed to be gotten somehow somewhere. Let me explain how this occurred. First off, let's understand a little how Microsoft manages their live and debugging environments. Microsoft's live environment is very restricted, as it should be. For an employee to access the live environment, they must use particular secure access workstations, dedicated accounts, and even go through background checks. On the other hand, the debugging environment just needs a valid Microsoft Cooperate account with a developer profile to access it. Also, there is what they call a zero-trust policy, where key material is not allowed to leave the live environment. As an example, let's say there is an issue in production and a developer needs to go through the logs. What happens is those logs will be moved to the debugging environment, and all key information will be redacted, so the developer cannot view any sensitive customer data. There are pipelines which detect and carry out this redaction automatically when moving this data. What happened in this case was that there was a crash dump in April of 2021 during a consumer signing process. If you don't know what a crash dump is, think of whenever your application or computer crashes. There is a step during the crash process where the state of the application or computer is captured to be used to restore it back if necessary. The crash dump, which normally redacts sensitive information, did not do so this time. Microsoft explained this was due to some race condition which occurred during the crash dump. Also, the pipelines for some reason did not identify the presence of the key information in the dump, which caused it to be moved to the debugging environment undetected. Stormy now was able to get access to the key by compromising a software engineer's account at Microsoft, which had access to the debugging environment with the crash dump containing the key. So what can we learn from this story? Firstly, even though cybersecurity has come a long way, there are still risks in using the internet, and as such we need to apply appropriate measures to secure ourselves online. You can check out the video attached on the top right, where we talk about some of the greatest hacks in history and measures to take to ensure safe usage of the internet. Secondly, we see how multiple flaws, which could have been avoided, came back to haunt Microsoft. It is important to always ensure appropriate practices are put in place and various edge cases are covered when designing a software system. And there you have it. Thanks for watching. You can support us by liking and subscribing to the channel.